So in the last video, we looked at vertical asymptotes. In this video, we're going to look at how to figure out what the horizontal asymptotes are going to be. So we have three different conditions. Bullet 1. When the numerator and the denominator of a rational function have the same degree, then the line y equals a over b is the horizontal asymptote, where a and b are the leading coefficients of the numerator and the denominator respectively. So again, bullet 1 holds only when the numerator and the denominator have the same degree. So they have to both be like first degree or both be second degree or so on. And if that's the case, then look just at the leading coefficients. The leading coefficient of the numerator divided by the leading coefficient of the denominator will give us the horizontal asymptote. Horizontal asymptotes are horizontal lines, so their equations will be in the form y equals a number, and that number will be whatever the leading coefficient is of the numerator divided by the leading coefficient of the denominator, again, if they have the same degree. Bullet 2, though. When the degree of the numerator of a rational function is less than the degree of the denominator, then the x-axis, or the line y equals 0, is the horizontal asymptote. The x-axis and the line y equals 0 are the same thing. We'll usually write the horizontal asymptote as y equals 0 if it's the x-axis. So if the degree of the numerator is, say, 2, and the degree of the denominator is bigger than that, say 3, then the x-axis, or the line y equals 0, will be the horizontal asymptote. So this was if the degrees are the same. This is if the degree of the numerator is smaller than the degree of the denominator. Bullet 3. When the degree of the numerator of a rational function is greater than the degree of the denominator, there is no horizontal asymptote. So if the degree of the numerator is, say, 3, and the degree of the denominator is smaller, say 2, then there's not going to be a horizontal asymptote at all. So we'll only get a horizontal asymptote when the degrees are the same or when the degree of the numerator is smaller than the degree of the denominator. So let's take a look at some examples. So in this example, we want to determine the horizontal asymptote of the graph of each of the following functions, if any. So if we take a look at these functions are the exact same functions that we found the vertical asymptotes for in the previous example. Now we're finding the horizontal asymptotes. So if we take a look at this first function, f of x equals x plus 3 over x minus 4. Notice that the degree of the numerator is 1. So the degree of the numerator is 1 because we just have x plus 3. And the degree of the denominator is 1. So we're going to have a horizontal asymptote. And the horizontal asymptote is going to be y equals the leading coefficient of the numerator over the leading coefficient of the denominator. Well, the leading coefficient of the numerator is understood to be 1. That would be 1x plus 3. So that's the leading coefficient of the numerator. Same for the denominator. We would have 1x minus 4. So that's 1. And y equals 1 over 1 is the same as y equals 1. So our horizontal asymptote is going to be the line y equals 1. Now if I pull in my calculator and take a look at this graph, so I'm going to put x plus 3 in parentheses divided by parentheses x minus 4, and if I look at the graph of this, we can kind of see that that line y equals 1 is the horizontal asymptote. In fact, let's draw that. Y equals 1. So there is the line y equals 1. So as x is going this direction, the graph is getting closer and closer to that horizontal asymptote, and the same is happening here. So in fact, we might say that as x goes to, that arrow means goes to, negative infinity, f of x is getting closer and closer to the value of 1. So again, as I'm going that direction, the value of f of x is getting closer and closer to 1. In the same way, as x goes to positive infinity, the value of our function f of x is getting closer and closer to 1. So we can say that as well. Now look at part B. We have g of x equals 2x squared minus 3x plus 1 over x squared minus x minus 6. Look at the degree of the numerator. The degree of the numerator is 2, and the degree of the denominator is also 2. So they have the same degree. So our horizontal asymptote is going to be y equals the leading coefficient of the numerator, which is 2. There is 2, the leading coefficient of the numerator, over the leading coefficient of the denominator, which is understood to be 1. So that is going to be y equals 2. So our horizontal asymptote is the line y equals 2. So if I bring back in my calculator here, let's just examine that. We have 2x squared minus 3x plus 1 in parentheses divided by parentheses x squared minus x minus 6. And if I graph that, can you see the horizontal asymptote? Let's go and graph the horizontal asymptote, y equals 2 as well. So we can see the horizontal asymptote. The graph, as we go this way, is getting closer and closer to 2, and the same is happening the other direction. So I could say as x is going to negative infinity, f of x is going to 2. It's getting closer to 2. And as x goes to positive infinity, f of x gets closer to 2. Take a look at part C. So here we have h of x equals x plus 3 over x cubed minus 4x, and that's our rational function. So looking at the degree of the numerator is 1. The degree of the denominator is 3. So in this case, the numerator and denominator do not have the same degree. The degree of the numerator is smaller than the degree of the denominator. So from our rule, that means that the x-axis is going to be the horizontal asymptote. Or the x-axis we could say is the line y equals 0. That's the same as the x-axis, and that is our horizontal asymptote. So again, just to kind of verify that, if I bring my calculator back in, we have x plus 3 in parentheses divided by x cubed minus 4x, and I have to also put that in parentheses. And if I graph that, we can see that the horizontal asymptote is in fact the x-axis, which is the same as the line y equals 0. So I can say that as x goes to negative infinity, the function value, I should say h of x, is getting closer to 0. And as x goes to positive infinity, h of x is getting closer to 0. And actually, even up here on part B, instead of f of x here, I should have said g of x is going to 2, and g of x is going to 2. So just to match my function notation here. Last but not least, let's take a look at r of x. So again, notice that the degree of the numerator is 1. The degree of the denominator is 2. So the degree of the numerator is smaller than the degree of the denominator. So that means our horizontal asymptote, like in part C, is the x-axis, or the line y equals 0. Again, normally we'll write that as y equals 0. Just to verify that, so I have parentheses x minus 4 divided by parentheses x squared minus 6x plus 8, close my parentheses, and if I graph that, again I can see that we have the x-axis has the horizontal asymptote. So again, I could say that as x goes to negative infinity, our function r of x is getting closer to 0 in value, and as x goes to positive infinity, our function is getting closer to 0.